Hi. So I'm going to talk about cross-site scripting, and I'm going to talk about ways that you can mitigate the risk that cross-site scripting is actually going to affect you. My name is Mike West. I work on Chrome at Google. I do some stuff in Blink. I do some stuff in Chromium. I'm happy to talk about any of that after this talk. It's really exciting stuff. I like Chrome a lot. I think you guys should too. You can go to my website. You can find me on Google+, on Twitter, whatever. This page is an exercise in seeing how many times I can write Mike West on a single slide. I think I haven't yet hit the limit. There could be an email, too. The slides are up online right now, and actually, you know what? I forgot to make them public. But they will be up online in just a moment. They're on Speaker Deck, which is awesome. I suggest that you all use Speaker Deck if you ever do slides. So it's after lunch. You guys have eaten a lot of food. You're probably very, very tired. You have room in your brains for one thing. And if you only have room in your brains for one thing, I would highly suggest that it be this thing. I'd really appreciate it if you just hit this article. It talks about content security policy. What is content security policy? Why should you care? Don't worry about it right now. I'll tell you. But please just bookmark this article, take a look at it. It's going to give you all of the practical information and all of the detail that I'm going to have to leave out in this talk, because this talk's like a half-hour long, and I could talk for days. No one wants that. Take a look at the article. I think it's really important, and I think it would be really helpful for you. How many of you have ever seen a page that looks kind of like this in Chrome or any other browser? That's not enough of you. You people are browsing boring websites. You need to branch out. There is so much of the web that you can explore, and you can get this page more often. You're not going to see this from CNN.com. You gotta dig around a little bit. This is a malware page, or a malware warning, brought to you by the magic of safe browsing. Safe browsing is a service that Google puts out that's used by Firefox, it's used by Chrome, and a variety of other services, non-browser services also, to determine whether or not a page is persistently malicious. That is, whether the page is always serving malware or always directing people to phishing sites. We've gotten really good at detecting these sorts of persistent threats. It's relatively easy for us to crawl the entire web and say, well, this page, nah, I don't like it too much. This other page, it's great. What we're not so good at are detecting the more transient threats, the threats that affect only a single request, or only a single logged-in user, or only all logged-in users for a service. It's very difficult to detect those sorts of things. Content injection attacks in particular are incredibly scary. I'll tell you why they're scary in a moment, but they're very, very difficult for us to detect, because generally speaking, content injection attacks come from, for instance, bad parsing of Git parameters. And if someone sends you an email with a carefully crafted URL that you click on and that owns you in some way, it's very difficult for us to detect that. It's very difficult for us to warn you about that. Content injection is scary because of this concept, the concept of an origin. An origin is a pairing of a scheme, a host, and a port. So HTTP example.com 80 and HTTPS google.com 443. Those are two distinct origins. And the browser is very good at effectively making sure that example.com never has direct access to any data from google.com. The origin boundary is a boundary that the browser can very effectively enforce. But that's the only boundary that the browser can very effectively enforce. The entire web is basically predicated upon the concept of the same origin policy, or security on the web is predicated on this concept. And this basically means that one origin should only have access to the data for that origin. It should only have access to its own cookies, to its own local storage, to its own databases, and so on. And this is something, again, that the browser can quite effectively enforce. What is the difference between these two blocks of script? That is exactly right. There is no difference whatsoever to the browser. Visually, we can inspect both of these, and we can say, the first of these script blocks is awesome. I really want to execute that. The second one, I have no idea how that got on my page. I don't want to be evil. Come on, this is craziness. It might, of course, have gotten on my page because I did something like this. Because I let the user define their own name, and then I write the name out directly without any sort of escaping. If the user calls themselves open script tag be evil close script tag, then I have a problem, because I've just injected code into my origin. And again, the browser cannot distinguish between code that I meant to execute and code that I didn't mean to execute. Content injection attacks are dangerous because they trick the server into serving content on its own origin that's going to do users harm and to do the application harm. These are all of the contexts in which an HTML page can find itself, or data in an HTML page can find itself. There's a style tag, so I'll put a color into style. I put a name into a paragraph. I put a URL directly into an attribute in an element. I put an ID into script, and maybe I have some debug information inside of a comment. The rules for escaping in all of these contexts are distinct. For example, inside of an HTML comment, 2 dashes will close the comment, and everything after those 2 dashes will be rendered. 2 dashes inside of a paragraph, of course, has no effect whatsoever. It just renders the 2 dashes. Now, escaping is actually quite trivial. The rules are easy. All you have to do is do it perfectly, every single time, for every piece of data that you have ever. You just have to be perfect. It's not that hard, right? These problems are trivial. But unfortunately, we are incredibly bad at trivial things. If you look at the history of the web, everyone has content injection holes on their website. Google has holes, you have holes. It's simply a pervasive problem on the web. It's one that we absolutely need to work on, and frameworks are giving us the possibilities to do this. There are context-aware escaping mechanisms. They've been around since 2009 at least. We're simply not using them, and when we do use them, we're not using them well. We should use them better. Nothing I'm going to tell you today is going to stop you from the necessity of actually escaping your data correctly. What I'd like to do today is to explain to you how you can mitigate the risk or mitigate the impact of the holes that are absolutely going to be on your site. For instance, does anyone know OWASP? O-W-A-S-P. OK, OWASP is great, and you seem to know who it is. I'll just say it's a security. They do security trainings. They do a variety of security sorts of stuff. And this is a really good resource for you when you want to learn about the variety of ways in which people can inject things into your website. These are kind of tricky things that you might not think about when you're putting things down. For example, you can have an entity that doesn't have a semicolon at the end. You just have to pad it out to the right length. So if you're checking for entities by looking for ampersand semicolon, then you're doing yourself a disservice, because that's not actually how HTML has to work. Hooray for HTML. Lots of exciting rules. Has anyone heard of JSFuck? Is Martin in the audience somewhere? No. OK, you'll probably hear about it a little bit later. JSFuck is awesome. It proves that you can express any JavaScript statement with only 6 characters. Open parentheses, close parentheses, plus, square brace, close square brace, and bang. With these 6 characters, you can write any JavaScript statement. That's kind of amazing, right? It's very exciting. But all of these characters are relatively benign. And I doubt that any of your filters are actually looking at any of these characters as being particularly dangerous. Does anyone know what this does, actually?
Oh, yeah, we can totally read that.
It's just JavaScript, right? I mean, this is pretty straightforward. It's alert 1, exactly. It's alert 1. Usually you would do alert XSS, like the string, but that's about 40,000 characters, so I didn't feel like pasting it in here. JSFuck has many things. Among them, it is verbose. Alex Russell puts this absolutely beautifully. He says, I discount the probability of perfection. And he's right. It's really hard to be perfect. It's really easy to make small mistakes. And unfortunately, small mistakes are all that it takes in order for a hole to be created on our site. And one hole is all it takes for data to be exfiltrated to a malicious third party. So I would rephrase this slightly. I would say we are all idiots with deadlines. We simply don't do the right thing, and we don't do the right thing not because we don't know it's the right thing, and not because we're not trying to do the right thing, but because we have other priorities. We have deadlines. We have things that are important. We need to build this new feature. We need to build this new page, and somehow securing the other pages and securing the page that we're building kind of falls through the cracks. It's kind of assumed that you're doing good security work. So again, it's really important for us to have the ability to mitigate the effects of the holes that we're going to create. Does anyone know what this picture is, or what this painting is? 1 person, 2 people. Culture, people. Come on, culture. This is Odysseus and the Sirens. It's from the Odyssey, which is a very, very old book indeed. The story is something like this. The sirens sing beautifully. So beautifully, in fact, that once you hear their song, all you want to do is hear more of this beautiful music. It drives you to the brink of madness. And since they live on an island, it particularly drives sailors to the brink of madness who come, somewhere near the island. Generally, you want to hear more of the music, so you throw yourself overboard in order to get to this island. Generally, the ship will crash. The sirens, I guess, eat people, who knows. And because of that, the sirens are incredibly dangerous, and sailors know to avoid this island and to avoid beautiful music. If you hear music, go away, because you're probably going to try to kill yourself shortly afterwards. Odysseus, however, is an incredible man. He is an egomaniac, and he's incredibly hubristic. And because of this, he says, I am going to be the only living person who has ever heard this song. I love music, and I really want to hear this, but I don't want to throw myself overboard, so how can I work around this? Well, after talking to a witch, he comes up with an amazing plan, and this plan is as follows. He tells his men to bind him to the mast, tie his hands behind his back, tie his legs to the mast, so he can't get away, but he can hear music, and he can talk to people, so I guess that's nice. He then tells his men to put beeswax in their ears and then bind their heads such that they can't actually hear anything that's going on around them. And he gives them very explicit instructions. He says, row in this direction, don't go to that island over there, just kind of go around it, don't throw yourself overboard, and just, keep rowing forwards. They go past the island, he's driven to the brink of madness by this beautiful music, but he survives. He survives because he prevented his men from doing things that would harm them all. It'd be really nice if your application could tell the browser not to do things that's going to harm the application. Perhaps that this piece of JavaScript is what I want you to execute. Please execute this piece of JavaScript. Do it as quickly as you possibly can, but don't look at these other pieces of JavaScript. Or rather, look at them, but please do not touch, right? Don't execute this stuff. Content security policy is this thing. I think it's beautiful. It's not beautiful, but it's really helpful. I edit the specification along with Adam Barth and Dan Vedetz from Google and Mozilla, respectively. They basically just tell me what to type, and I type it because they're much smarter than I am. But I have the opportunity to be here with you, so I think I get the better portion of that deal. Regardless, content security policy is a language that defines a mechanism by which you can give a whitelist to a browser and say, script from this origin, awesome. Script from that origin, not so much. Please execute this, do not execute that. It gives you exciting errors like this. Refuse to load the script, example.com evil.js, because it violates the following content security policy directive, script source self. We'll talk about what exactly that means in a moment. This is what a content security policy directive or a policy looks like. It's an HTTP header delivered when you deliver the page. It contains a semicolon-separated list of directives, each directive giving you granular control over a particular type of content. This is the policy for an incredibly high-value website, mikewest.org. You may have heard of it. It's really, really important. You should all visit it. We start by setting a default source of none, which basically means for all the types of content the content security policy gives you control over, load none of it. None is the only acceptable origin, which means don't load any content. Then we slowly open that up, and we say, OK, load no content except style from my CDN, and you can also open frames from these sources. You can open some script and execute it, and you can open some images from over here. So what we've done here is basically started with a closed door, and then only let in those types of content and those origins of content that we actually trust. Now, what I'm showing here are just origins. It's actually the case that both Chrome and Firefox support the 1.1 syntax, which allows you to have paths. So you can say, not only script for my CDN, but only script for my CDN that's in this particular directory, or even only this particular file, if you want to be that granular. It gives you a lot of control, and although I don't think most people will be that granular, there is a lot of value to doing so if you want to. This is a relatively exhaustive list of all the directives that are in 1.0. We'll go through as many of them as we possibly can. The ones that you haven't seen yet are things like connect source, which determines where you can make XHR requests, and also event source and things along those lines, and sandbox, which allows you to apply a sandboxing policy to the document that's being loaded on a page. You've heard of iframe sandboxing, I hope, and if you haven't, you'll hear about it at the end of the talk. Sandbox directive allows you to apply a sandbox to the page that's currently loading, which you don't currently have the option of doing. It's actually quite powerful. What you also see at the bottom there is report URI. Report URI is very important. It allows you to find out when your site is being attacked. If you have a policy on your site, and there's a violation because a script was injected that you didn't expect, this gives you a post back to a specific endpoint on your origin. And this post contains some useful information. It tells you what document was being attacked. It tells you what the attack kind of looked like, what the source file was. If we can find a line number and a column number for you, we'll do so, and we'll give you that information so that you can start figuring out where the holes are in your website. What you see at the top here is content security policy report only. So what we have is the ability not only to enforce a policy, but also to have a report policy happening at the same time. So you can slowly roll this out on your websites by first reporting violations and then moving to enforcement once you think you've closed all the holes. This gives you the ability to also have two policies active at the same time. One relatively loose policy that you enforce, for example, HTTPS only, and one policy that's a little bit stricter that you put in report-only mode for a little while until you're confident that your site actually matches the policy that you've written. Now, some people don't like content security policy so much. There are really two complaints that I've heard about content security policy. Actually, before I get into this, who in the audience was familiar with content security policy before this talk? Okay, a couple of people. That's actually quite good. Has anyone implemented content security policy on their websites? Okay, a couple of people. Please talk to me afterwards. We very much want feedback. We're still in the process of doing 1.1, and any feedback that we can get is good feedback. So, Rick Waldron. CSP designed by ignoring reality. So there are two things that Rick believes are ignoring reality, and I kind of agree with him. We want to change reality. We have looked at reality, and we kind of don't like it so much. So we've invented our own, and we're trying to roll it out as well as we possibly can. One piece of reality that is problematic are inline scripts. Inline scripts are the biggest problem on the web, period. They're the biggest problem on the web because, well, what origin does this come from? It comes from your origin, right? But if we allow self, then that's not only inline script on your origin, but also external script from your origin. So we've invented a new origin for this called unsafe inline. We call it unsafe inline because it's kind of unsafe and we kind of don't want you to use it, so please don't. But if you want to, you can whitelist it. Haha. What we would suggest, however, is that you externalize the script to whatever extent possible. You pull it out into an external file. The browser can verify that this file is coming from an origin that you trust, and then it'll execute on the page. So you need to do something like this, where you externalize the file, you do some DOM manipulation to attach event handlers, and you go from there. What's in 1.1 that we think is going to be a better solution? Well, actually, what we've done in 1.0 is basically thrown out the baby with the bathwater, right? We know that there are good uses of inline script. We know that it's performant. We know that there are some latency issues. However, in order to get something out the door that's useful, we've thrown all that out as well. Inline script is just banned by default. In 1.1, we're kind of going to look in the water and see what babies we can pick back up. And hopefully we can get a couple of them, because babies are nice. One thing that we're trying to do in order to allow certain types of inline script is using a nonce. You send a nonce as a valid origin in a script source. This nonce is then repeated as a nonce attribute on scripts that come into a page. This allows the browser to distinguish between scripts that the page injected. That is, if the page knows the secret, it can execute the script. And if an attacker hopefully doesn't know the secret, then it won't be able to execute script because they won't be able to get access to the nonce. This is one thing that might work pretty well. There's another proposal being made by Twitter, Neil Mittal, who's doing a great job putting together some additional pieces to the spec that'll be doing hashing. So we'll basically send a SHA-256 hash as a valid source, and then if a script that matches that hash appears in line, then we'll execute it. So there's still a lot of work to do in order to make sure that these, to figure out which of these we actually want to implement, and then to actually spec them out and implement them. Nonces are available right now in Chrome. So if you go into Chrome flags, turn on experimental web platform features, you can start playing around with nonces right now. We think that's going to be relatively effective. And what's nice about nonces, they have the property that they're transferable. So you can, if, for instance, you embed an ad into your page, which many people do, then you can give the ad network the nonce as a get parameter, and then they can inject script into your origin as well. So for a lot of use cases, this transferability is very powerful. It gives you more of a system of capabilities by which this nonce gives you the ability to execute script or put style in line. We think that has some good properties. The other thing that ignores reality is eval. Eval is problematic because if you allow people, or people will be able to inject things onto your page. And if you read data from your page and then eval it, you're opening yourself up to potential attack vectors. So it's a more reflected DOM attack as opposed to just something coming directly from a GET parameter. We ban eval by default as well. You can turn it back on by allowing the unsafe eval origin. Again, unsafe, we kind of don't like it, but if you really need it, then go for it. I think there are better mechanisms by which you can do eval. Eval is problematic because it executes in the context of your origin, just like every other piece of script in your site. You can get around this with sandboxing. There's a good article written by a very handsome man that explains how you can inject an iframe into your page, sandbox the iframe such that A, it's not coming from the same origin, and B, that it doesn't have any permissions that it doesn't need. It can execute script, and that's basically it. You can pass information into this script or into this iframe. It can do some processing and then give you some data back. And if the processing is exploited within the context of that iframe, even if you then inject like inner HTML with the data that you get back, that's protected by the policy of the larger page. So the iframe doesn't have a policy, but it's sandboxed. Your page has a policy, which means pass information, throw it over the wall, get something useful back, and then do something with it. And you don't have to trust that relationship. And if it executes bad code, then that's kind of OK because it didn't have access to any of your useful data. So I'd highly recommend that you at least take a look at this. There's a demo here that shows you how eval works within the context of an iframe. You basically have an iframe, does some processing, and it just evals code directly and then gives you the result back. And you can play around with that a little bit. It's a good demo, I think, of the concept. So I'd highly recommend that you take a look. I called this talk, actually, I'm sorry, this is the article again. Please read it. I think it's really important. This gives you all of the practical detail that you're going to need in order to actually start implementing this on your sites. And that's really what I want more than anything else. I want people to start implementing this, and I want those people to give feedback to the working group such that we can construct 1.1 in a way that really meets your needs instead of meeting most of your needs, which is, I think, where we are right now. I called this talk what did I call this talk? Towards a post-XSS world. And I called it that because of this article. This is a great article published, I think, at the end of 2012 called Postcards from the Post-XSS World. In other words, exciting security researchers are already figuring out how they're going to be attacking you once script is no longer allowed on your site. It is possible. It is not that difficult. Basically, what content security policy is going to do is allow you more granular control over the script that executes on your site, over the style that executes on your site, and a variety of other resource types. I'd really highly recommend that you be as restrictive as possible in those resource types. However, it's still the case that content injection attacks can be dangerous. They can still exfiltrate data. People are coming up with really exciting ways of doing things. The metaphor that's used, or the analogy that's used in this document, is that content security policy is kind of like address space randomization for applications. It doesn't actually prevent attacks, but it raises the bar for attacks. It makes it more difficult. And the more difficult attacks are, the more likely attackers are to move to less difficult targets, which I think is good. So if you're in the woods with your friends and you see a bear, and the bear rears up on its hind legs and roars at you and starts running in your direction, you're all going to turn around and run away. You don't want to be the slowest in that group. You want to be the fastest in that group, or at least somewhere in the middle. Content security policy gives you a little bit of burst of speed, such that you are not the easiest target. It gives you a lot of control over the content that's executed on your site, and because of that, it mitigates, to a large extent, the impact of the content injection attacks that are absolutely going to exist on your sites. I highly recommend you take a look at it. Thank you for your time.